हेलो फ्रेंड्स। तो हम लोग फ्लूइड प्रॉपर्टीज से रिलेटेड क्वेश्चंस को कंटिन्यू करेंगे। तो आज का क्वेश्चन आपकी स्क्रीन पर। तो द क्वेश्चन इज सेज अ फ्रस्टम व्हिच इज रोटेटिंग एट अ एंगुलर स्पीड ऑफ 250 radian per second in a container which is filled with oil viscosity of 0.1 pascal second and the thickness of oil film which is 1 mm. Then we have to determine the power required. So, and the second part says if the temperature raises to 80 degrees centigrade, then viscosity is also changes. Then we have to find the reduction in power input. So the angular speed, which is given as 250 radian per second, the viscosity, which is zero point 0.1 pascal second, and the oil film thickness, which is 1 mm. So, as we can see, the first term, which is surrounded with the oil, and it has a varying cross section. So we know the shear force, which is shear stress into area. So if area changes, then shear force is also changes, and the torque is also changes. So because the area bottom to top and side are changes, so we need to calculate the torque for all three surfaces. So the area is varies in radial direction, so we use the integration method to determine the torque. So for the bottom surface, first we determine for bottom surface. So say a strip which is the thickness of dr and slant height, this is ds. Now the force acting on this strip, which is a df, which is the tau into dA. So if we consider the velocity profile within the oil, which is linear because it is very thin, so this is v by h, area which is 2 pi r into dr. So torque, which is a dt, this is the dt, which is the r into df. So if we substitute the values, this is v by h, this is r, and v can written as, that is tangential velocity, which is r into omega into 2 pi r into dr. So again, the torque, which is acting on this element, which is dt, which is this is mu omega pi mu, or this is 2 pi mu by h into, this is the r cube into dr. So if we find the total torque, so we integrate it. This is, that is 0 to r1. So this is T bottom, which is 2 pi mu omega by h into r to the power 4 by 4. So this is the mu pi omega r1, this is r1 to the power 4 . This is r1 to the power 4 by 2h. So if we substitute the values, so torque at bottom, which is the mu is, this is 0.1 pi into omega, which is 250, r1, which is 2 centimeter, that is 0.02 raised to the power 4, and divided by 2h, which is 1 into 10 to the power minus 3. So this comes out to be, this is 0.0016 Newton meter. Now the torque at the top surface. So torque at the top surface. So similar way we can calculate it. So torque at top surface, which is the mu pi omega r2 to the power 4 divided by 2h. So if we substitute value, this is mu, which is 0.1, into pi into omega, which is 250, r2, which is this is 6 centimeter, that is 0.06 raised to the power 4 divided by 2h, which is 1 into 10 to the power minus 3. Now this the torque at the top surface, which is the 0.127 Newton meter. This is the torque at the top surface. Now the torque at the side surface. So the side surface, the area, which is the 2 pi r into ds, that is length height. So and r is varies as r1 plus r2 minus r1 by l into z if this height is z. This is z. So if we differentiate it, this is dr, this is r2 minus r1 by l into dz. So this is the dz. This is the dz. So here we get dz is equal to the L by r2 minus r1 into dr. Now we substitute this value in area. So this is dA. So here we get dA is equal to the 2 pi r into L by r2 minus r1 into dr. So torque on side surface, that is torque on side surface, which is the integration of mu omega by h g. This is the r1 to r2, this is r square into dA. So this is mu w by h mu omega, sorry, this is r1 to r2, this is r square dA, which is 2 pi l into r2 minus r1 into r cube. This is the r. This one is here, this is 2 pi r L by R2 by R1 into R dr. Now again if we simplify it, so this is 2 mu pi omega L by H into R2 minus R1 integration R1 to R2. This is the R cube dr. So after integration we will get, this is pi mu omega by L into H R2 minus R1 into R2 raised to the power 4 minus R1 raised to the power 4. Here we have 2. Now we have T side torque. Now we substitute the values. So this is T side, which is pi into 0.1 into 250 into length, which is the 10 centimeter, that is 0.1 into 0.06 raised to 4 minus 0.0 raised to 2 divided by 2 into 1 into 10 to the power minus 3 into 0.06 minus 0.002. Sorry, 0.02. So this side torque, which is the 1.265 Newton meter. So we have calculated the torque on 3 surfaces. So the total torque, which is T is equal to the T bottom, T side and T top. So this is the 0.0016 plus 1.65 plus 0.127. We get, this is the 1.3936 Newton. The power we have to calculate the power required. So power required, which is the torque into angular velocity. So this is the 1.3936 into 250. So this is the 348.4 Newton meter. Now the second question says, if the temperature increases, then viscosity changes, then what will be the reduction in power? So we know the torque is proportional to the force and shear force, and shear force is proportional to the shear stress, and this proportional to the viscosity. So power will proportional to torque, so power will proportional to the viscosity. So now the power, this is at 20 degree. So power at 80 degree centigrade, which is the viscosity at 80 degree centigrade divided by viscosity at 20 degree centigrade into power at 20 degree centigrade. If we substitute values, this is 0.007 divided by 0.1 into 348.4. So power at 80 degrees centigrade, which is the 24.338. This is the watt, not Newton meter, this is watt. Now the percentage reduction in power. So percentage reduction in power, which is the this is the 348. This is the 348.4 minus 24. This is the 338 divided by 348.4 into 100. So this is 93%. So if it changes the viscosity temperature, so viscosity will decreases, then power will also reduce by 43%, 93%. Thank you.